is Batseba. Batseba Ngabani. So we're still continuing with differential calculus. And this is my email address. My email address is Batseba, my name, Ngabani, and surname @gmail.com. So my email address is my name and surname @gmail.com. Okay. So please note down my email so that if you have questions later on, then you can just send me an email. Okay, so during the lesson, just make sure that you're on mute and your videos are off. So please make sure that you're on mute and your videos are off. And also, we're gonna have a question and answer session at the end of our session. So during the session, you can jot down any questions that you would like me to answer. Okay, so we have questions at the end of the lesson, or you can send me an email. Remember my email address, my name and surname @gmail.com. And then this is very important. Please note down the exercise number. So please note down the example. So if it's an example, note down that number or the exercise number so that you can refer to it when you ask me a question. So it will be easier to move back to the slide you want to ask me about. And then also remember, we only have math related questions in our chat. So we only do math related questions in our chat. No personal conversations or any other thing that's not related to our math. So please, only math related questions in our chat. So at the end of the lesson, we're still doing derivatives of functions using first principles. So we're still working with limits. Okay, so we're doing the derivative of a function from first principles. So we're going to start with the homework corrections. And at the end, you can ask me questions. So this is exercise 1. Please note that down. Exercise 1. Okay. So if you're given a function, so this is your function. Your function is g of x equals to 1/4. And you're asked to differentiate. So this is what you have to do. You need to differentiate. You have to differentiate using what? First principle. And then you also have to say something about your answer. So we're going to differentiate this function here. And our function is g of x equals to 1/4. Just by looking at the function, you can already see that it's a straight line, isn't it? So please just revise functions because it's very important because we work with functions. So just revise your functions, the shape and everything. Okay. And then we agreed that after the first thing that you do is to write your notation. So this prime just simply means you're doing the derivative. So you write your g prime of x equals to, and then you write your notation. So our notation is the limit as h approaches 0 of our g of x plus 1 plus h, sorry about that, minus that. But what you need to notice about this function is that this is the standard form. So this is usually the standard form of a straight line. And we know that the m represents the slope or the gradient. This corresponds to that y x value. And then this is our intercept. So this is our y-intercept. And if you look at our function, this term is not there, it's eliminated. So it means we have a function that's passing through at this point. And where? In the positive y-axis. So we have a function that's passing through this point in the y-axis. And the reason why I wrote this down is just to show you that if you're given a g of x, because I think there was a mini confusion. If you were given a g of x, and this is your function, g of x plus h simply means in the place of x, you replace with x plus h. So wherever you see an x, you replace with x plus h, isn't it? So wherever there's an x, you replace with x plus h. Then you go back to your function. Where there's x, you replace with x plus h. But then in this function, we do not have a part where we can replace our x. So we don't have this part. And we also don't have this part. So in this case, our g of x is the same as our g of x plus h. So they are both equal to 1 over 4. So when we substitute into our equation, hence we have 1 over 4 minus hence we have 1 over 4 minus 1 over 4, because our g of x in this case is the same as g of x plus h. But it's not always the case that our x is equal to g of x plus h. You need to check. But then this simply means in the place of x, you replace with x plus h. Okay. And then after that, we simplify. A quarter minus a quarter is 0. Then 0 by h is that. So this is our g prime of x. And then if you also want to confirm that using a function, you can see that, oh, this is actually a straight line. So this is our function. It's a straight line going through this point. So the gradient is 0 because our value of y is constant. So your change in y will be 0. Yes, x is changing, but then your change in y will be 0. Hence, it's the gradient of this line is 0. So you should also revise let me see, I can do this. So you can do, or actually you can do the same problem, but then now with vertical. So you can try the same problem and then try, okay, if this function was vertical, then what would happen? You will realize that the gradient is undefined. So the drawing of the graph, it can help you just to see if you are on the right track. So if they didn't say you should draw the graph, you don't need to draw the graph. But then you can just draw your graph just to see if what you're doing is right. Okay. And then moving on. So how I interpreted my statement is that the gradient and the derivative of the function g of x is 0. Okay. And our second exercise, we have p of x equals to 4x into x minus 1. And then you need to determine the derivative of this function using first principles. Okay. So already from this, you can see that if you were to substitute x plus h here and there, it would be confusing. So what you need to do is to simplify this equation first. So how do you do that? You go 4x multiplied by x, which is your 4x squared, and then 4x multiplied by -1. So positive times negative is negative. And then that times 1 is 4x. So you simplify it first so that it's easier for you to see that in the place of x, you're going to replace with x plus h. So our p of x plus h, now we do have a term with an x. So whenever we see an x, we replace with x plus h. So whenever there's x, we replace with x plus h. So where there's x, replace with x plus h. Where there's an x, replace with x plus h. Then you can write your notation. Remember, this is not given. You need to know this. You need to remember this. But it's very easy. So it's just you're changing y over you're changing x. Okay. So now you plug in what you solved here. Because this we know that it's x squared plus 2xh plus h squared. And then, so that you don't get confused, this part is actually, so this is your okay. And then this negative, it's simply saying your negative times 4x squared, you get negative 4x squared. And then your negative multiply. So negative times negative is positive. Remember that. Okay. So hence you have negative 4x squared plus 4x. And remember this whole process, while we're doing this, we have h in the denominator. And if you just substitute that value of 0 in the place of h, you'll have a function that's undefined. So we're trying to find a way to simplify this. Okay. And then you look at your like terms. And then you remain with 4x squared, because this is 4 times x squared, 4x squared. This times that is 8xh, 4 squared, And then this one will cancel that one. Okay. And then minus h. And then also in this step, you have this 4x squared minus that. And then what you will all notice is that all these terms have a h, so you can have your h as a common factor. And then that's how you simplify. So to check if your answer is correct, you can multiply the h with all these terms and see if you still get that. For example, h times 8x is 8xh, h times 4h is 4h squared, h multiplied by that is that. So you multiply each term with the h and then you get that. That's how you check if you did the right thing. And then your h will cancel your h. And then you'll remain with a term like this. And then now you can easily substitute your h with the value of 0, this one. So this term becomes 0. Because if you plug in 0 in the place of h, then that term falls away and then you have that. So this is our p prime of x. So this is our derivative. Okay. And then going to the next one. Sorry about that. This is actually exercise 3. So this is the third exercise. Sorry about that. So this is exercise 3. So if you were to find the derivative of a function, still using first principles, we do the same procedure. In the place of, when we get our f of x plus h, in the place of x, we're going to replace with x plus h. So remember, it's always good to solve them separately so that you don't miss marks somewhere. So just write them separately. Show that you know this is your f of x, and show that you know that in the place of x, you replace with x plus h. And you will get marks for that. So this, in the place of x, you replace with x plus h. X plus h, x plus h. And don't forget this negative. Don't forget this negative in front of the 2. Okay? And then now, when you simplify, it will show that, okay, this is, because remember, this x plus h, this is actually so x plus h squared is simply x plus h into x plus h. Okay, so now that's how you simplify to the next step. So you identify your f of x, you also show your f of x plus h, And then you also write your notation. And then you can even simplify. Instead of simplifying in the equation, you can simplify here before writing your notation. Then you just simply show that, okay, now I have my -2 into x plus h squared and that. So you can even show with the brackets that this is one term. Okay. So this is the simplified form of that. And then you have 3 times x, which is 3x. And then the 3h is that one, and that's the one taken up. And then you have a negative multiplied by a negative, which is a positive. You have a negative multiplied by a positive, which is a negative. And then you have a negative times positive, which is negative. So please, please, please. These are some of the things that we make mistakes when we write exams. If you miss a sign, then the whole thing is gonna be wrong. Okay. So now you'll have negative 2x squared minus 4h, because it's that times that 2, and then negative times positive, please remember. And then negative times positive is that, plus 3h plus that. Okay, because remember, after you simplify, you look at your like terms, because this will cancel that, for example, and that will cancel that. Okay, then you remain with that term. And then the 2, that. And then all our terms have a h. We can make our h a common factor. So you'll have h into, remember, this you can check by multiplying to see if you get that. So h times negative 4x, you get that. H times negative 2h, get the second term. And then remember, negative times positive is negative. And then you remain with that term. And then as h approaches 0, we use our substitution rule. We substitute 0 into the h. And then this term falls away. And then this is our derivative. Okay. So these are the solutions to the homework. And then if you still have a question, so this is your homework. It's questions from question paper. So you see all that process gives you 5 or 6 marks. So you need to make sure that you maximize on this. Okay, so this is your homework. That means tomorrow we're gonna do this. It's questions from previous question papers. So we're gonna do this, and then we wrap up what? We wrap up our derivative from first principles and limits. So remember to go to Siavula your textbooks, and then we're also gonna do question papers from our DBE website. Okay. And yeah, so remember to follow us on social media and also go to our website for sessions that you missed so that you can catch up. Okay. Now you can ask your question. Okay. I think Kyle has a question. So remember, this is your homework. Okay. So now we can do question file. Mhm. Kyle,
You should read it.
Kyle,
You wouldn't know.
I think it disappeared.
Okay. No, you're coming. I must be. Yes, you are. No, I'm not.
Okay. Do you guys have a question? Okay, there's someone in the group who asked, okay, let's say you're given a function, for example, you have to find the derivative from first principle, and you're given, okay, let me go back. It's in relation to the, so let's say in this case, you're given, I'm gonna try to use different color. Remember guys, you can raise your hand if you have a question or if you don't want to ask in the group. So let's say you're given a function f of x which is equals to 2x. You're supposed to do differentiate using first principles. Remember, the notation is still the same. So when you calculate your f of x plus h, remember we need two important things. We just need our original function and f of x plus h. This will be equal to 2 of x plus h. Can you see the difference now? Because in this case, we didn't have a term with an x, but with this question, you have a term with an x. So in the place of x, you replace with x plus h. So this simply means that your f of x plus h is 2x plus h. Okay. So this is what you simply gonna do. And then if you're given a function of f of x, which is for x plus 1, my bad, for x minus 1. So your f of x plus h will be f of x plus h minus 1. So this is simply for x plus 4h minus 1. And then you just plug in f of x into the equation and your f of x plus 1 into the equation. Okay, there's a question from Cheslin. Remember, tomorrow we're going to do the questions from the homework, which are from question papers, to see how we will be marked. And then we're going to close this chapter and then on the part where we're doing limits, and then we're going to do that. So let me unmute. Tepiso. Hello, Tepiso. Okay. There's Cheslin. Cheslin?
Hi.
Yes, you have a question with regarding to this question.
Yes, with this question, at first I struggled with it because there was no x in the thing, and I know usually we substitute x of h where x is, and there was no x. But going over the rules, the one rule says if f of x is equal to a constant, then since there's no, it'll be equal to 0. So can we just use that, or do we have to use the first principle and do all these steps?
Remember, that's why I keep emphasizing. I know there's other simpler rules for solving derivatives. I know that, and I know you know them. But if the question states, because even the homework, it's from a previous paper, there are questions where they state using first principles, so you have to know it. I know it's very long, but you will be, there are questions where they test you on first principles and then the other rules of derivatives. So you have to know all of them. So if they ask you,
So if there's no x, which is what we usually substitute into x of h, and then we get all the things we need to put into the formula, we must just use the function straight as it is.
Yes, because that's what I was trying to show you, that you only replace x plus h when you see an x. That's why I'm trying to show you now with all, because there's someone who asked in the chat, like, okay, what if now I have 2x, or if I have 4x minus 1? Then because you have an x in your function, that's when you can replace it with x plus h. But then if you don't have an x in your function, then you simply use the function as is, because where are you going to substitute the x plus? Can you see that?
Yes, ma'am. That's why I was wondering, because there was no x and I was doing it yesterday and I didn't understand.
Oh, okay. And then the graph also helps you to see what your gradient is. Remember, we learned how to calculate the gradient like when we're doing functions. So if you look at a horizontal line, the gradient is 0. That's why I was saying you should also check if the line is vertical. Because imagine if you get to a test and they give you the same question, but then now you have a vertical line. How are you going to do that? Yeah. So it's something for you to think about.
Thank you, ma'am.
It's a pleasure. Let's go to Okay. Tepiso?
Yes, ma'am.
Yes.
Ma'am, I would like to know the importance of this lum h to 0. Like, how important is it? Like, what effect will it make if you don't put it in your equation?
Okay. Remember, when you use it's a law. I can just say it's a law. According to first principle, this is how you find your gradient. Were you in class when we were deriving the formula?
Yes, ma'am.
Yes. So there's different ways of finding the derivative or the gradient. So this is one of the ways in which you have you find the gradient. Because if you remove, do you realize that if you remove the limit, then this equation doesn't hold. Because you're simply gonna do y2 minus y1 divided by x2 minus x1, which is not the derivative.
Okay, ma'am. So you will not gain marks if you don't put it in the equation.
Yes. If it's like I don't know how it's a law that it's I don't you won't get marks. Let's just say you won't it will mean something else. It won't mean the derivative, because the derivative is when the limit of h, because you remember we derived it and we explained why we have to use it like this.
Okay, ma'am.
Yeah, but it's easy. The
Ma'am,
more you
explain to me this, like the g of x, like this derivative of the g of x, like, is it also necessary to put it like after every equal sign, or just from the beginning and just the end?
You mean, do you have to show g prime x in all these steps?
Yes, ma'am.
Or no,
Yes.
you don't have to.
Oh.
Yeah, because but then remember you showed it in your first step that g prime of x is that, and then now you're just simplifying. But then at the end you can just show that, okay, this is my g of x prime. But if you eliminate it like this, it's not like you're gonna lose marks, because from the beginning you showed what you are doing.
Oh, okay, ma'am. Thank you.
Yes, it's a plane. Yeah? Okay. Okay, guys. Do you need clarity with one of the questions? Okay, we have 5 minutes. Remember, tomorrow we're gonna do questions from a previous question paper. So this is your homework. It's similar to the problems we were doing. So just try this, and then so that we know how the examiners mark our steps. And then we'll just do a brief introduction on rules of differentiation. And then from next week, we'll use other, because this is one way of doing differentiation for finding the derivative. But then there's other simpler ways. But you need to know this. Unfortunately, it's part of your curriculum. So you need to know this. And then we'll also learn other ways of calculating the derivative. Okay. So do you guys still need help? Remember, if you still have other questions, please send me an email and try the homework, because 6 marks is a lot. When you're writing an exam, it's a lot, and it's easy marks, so it's very easy. So just try it, and then tomorrow we wrap up differentiation using first principles. Okay, let's take last question. So guys, remember, if you still have questions, then you can send me an email. And my email address, it's my name, so try the homework, and then tomorrow we wrap up finding the derivative using first principles, and then we learn new methods, I think easier. But even the limit, the more you practice, you'll actually see that, this is easy 6 marks or easy 5 marks. Because you just have to know your f of x, and you know your f of x plus h, you simplify, and then you write your notation. Then you plug it into your equation, plug in your f of x and f of x plus h into your equation, and then you are sorted. So any other questions before we log off? Okay, guys. Remember to go to our YouTube channel and our website for any of the lessons that you missed. Okay. So we'll meet tomorrow, same time. And if you have questions, just send an email. Great.